we're focused today on similar figures, and at the end of this lesson, by the end of this lesson, you'll be able to determine whether figures are similar using proportions, and also find missing dimensions using a scale factor. So copy down your target. While you're doing that, notice I put a picture of some nesting dolls. I don't know if you've seen these before, but they're traditionally Russian nesting dolls, but they're really in a lot of different cultures. They say the Chinese had the first set of nesting dolls. They were boxes, and many different cultures have used them. But these are little collectibles that I've seen growing up, and they are similar figures. The proportions should be the same within each piece, but they're the same shape, but they're not the same size. So we took the big doll and shrunk it down multiple times to get the smaller ones. And that's going to be the idea of similar figures. Congruent figures have the same shape and size, whereas similar figures have the same shape, but they are not necessarily the same size. So we're going to be focused on these figures today. Within similar figures, we have these special relationships that exist. All the corresponding angles are still congruent. So notice angle A would be the same angle measure as angle A prime, and angle B would be the same size as angle B. The angles don't change, okay? They stay the same, but what happens is the lengths on the sides change. The corresponding side lengths form equivalent ratios. So take a look here. That means if AB corresponds to A prime, B prime, they're the same side of each triangle, their ratio, this side divided by this side, would be equal to the ratio of the other corresponding sides. It would be equal to this side divided by this side, because those are corresponding, which would also be equal to the side CB divided by the side C prime, B prime. So the ratios of the corresponding sides are proportional. The ratio formed by the corresponding sides is called the scale factor. So the ratio formed by the corresponding sides is called the scale factor. And the scale factor is always going to be written new over original. So I want you to write that on your notes. Write that in underneath scale factor or next to scale factor. Always do the new over the original. So remember, in similar figures, the angles have the same measure. The lengths form equivalent ratios, or they are proportional. So let's use this to solve for missing lengths. Miss Rummel took a picture of the Fort Couch Student Council and had it printed as a 10-inch tall by 14-inch wide picture. When posting this picture to the Upper St. Clair webpage, she scaled it down to be 4 inches tall. How wide should the picture be on the webpage for the two pictures to be similar? So when you think about this, you know, we've seen it before. I've seen it before. You click on a picture, you shrink it, you don't shrink it the right way, and it looks funny. I could even do that with this picture right here. If I shrink this up, she stayed the same width but not the same height, she doesn't look right. She looks disproportional from where she was. So we want to shrink the height and the width together. Start with the course. I think it's best actually to start with a picture. So Ms. Rummel took a picture, and it is 10 inches tall by 14 inches wide. So here's my 10-inch tall, here's my 14-inch wide picture. She's going to shrink it down, so it's going to become smaller, guys, and it's going to become 4 inches tall. And I want to know how wide it's going to become. So this is the part I don't know. When you don't know something in math, what do you use? A variable. So let's make it x. It's going to be x inches, but I'm not sure how long it should be, how wide it should be to keep the picture proportional. We can set up a proportion to find this. These two objects are similar figures, and we know that similar figures, their ratio of the corresponding side lengths form equivalent ratios. So let's write a ratio for the corresponding side. Remember, I always like to set it up as new over old. Okay? So my new height is 4, and 4 corresponds to what? So this is my new height, and I'm going to put the height on the bottom too. 4 on my new picture corresponds to 10 on my original picture or my old picture. Well, that should be equal to the ratio of the other corresponding sides, but you need to make sure you write it the same way as the first. So we started here with this image, and then we went to this one. Do that same setup on the other fraction. 4 over 10 is equal to x over 14. Now this is just one proportion that will work, but now we have a proportion and we can solve. The way we solve a proportion is we cross multiply. We saw that from our earlier lessons. So we can do 10 times x is equal to 4 times 14. So 10 times x is equal to 56. And then you can divide by 10 to get x by itself. And now x is isolated, and you have an answer. What were we asked to find again? How wide should the picture be? So your answer should have a units on there. How wide should the picture be? 5.6 or 5 6/10 inches is the width of the picture to keep it proportional. Again, this proportion could be set up more than one way, but that's the way I like to set it up. Let's try another one. An ant is looking up at a tourist taking a photo of a lighthouse and realizes that from his view, the top of the tourist's head lines up with the top of the lighthouse. The ant and the tourist are 4 meters apart. If the tourist is 1 6/10 meters tall, how tall is the lighthouse? So I know how tall the man is. The man is the tourist is 1.6 meters tall. So let's put that in our picture. And the ant is 4 meters from the tourist. That's already in our picture. And what else do we have? It looks like on this picture we also know that the ant is 75 meters from the lighthouse. Now we need to have similar figures, so you actually need to pull this picture apart. I'm going to pull the ant out. The ant forms a smaller triangle with the tourist. So here's my tourist, and I know his height is 1.6 meters, and the ant is 4 meters from him. The whole length of the triangle then is 75 meters. The whole length of the triangle is 75 meters, and the height is what we don't know. We have two triangles here. We have this little one, and then we have this big one right here. Set up your ratios of corresponding sides. So let's see. Remember, I like to do the new to old, although here we don't really have a new one. I'm going to start with my ant triangle. So this is going to be my first triangle, and this is going to be my second triangle. Well, the distance of 4 corresponds to what length on my second triangle? This is like the base, so this would be like the base. So 4 over 75 is equal to, now I'm going to go, again, back to my first image. I have my height, and I'm going to write that over my other height. So 1.6 over x. Notice how it matches up. This is base of the small to base of the large, and this is height of the small to height of the large. There has to be that symmetry that exists within your ratio, within your proportion. You couldn't just flip these two. That would not be a correct proportion. Now you can flip the whole thing, but that's a different story. So let's solve this now. How do we solve a proportion? We cross multiply. So 4 times x equals 75 times 1 6/10. You can use your calculator here. How do I get x by itself? So we have x is equal to 30. Now what did the question ask for? The question asked, how tall is the lighthouse? So I need to put a unit to my answer. My lighthouse is 30 meters. The units will match what you're talking about in the picture. All of these were meters, so your answer is going to be in meters as well. Now you could be given a scale factor and asked to find the new dimensions of a figure. I've heard there's lots of movies and stories that talk about this. Think about Alice in Wonderland. She shrinks down and then she enlarges. Another story that reminds me of is Dr. Seuss when we talk about the Grinch. So the average adult heart is about 5 inches tall, 3 inches wide, and 2.5 inches long. Dr. Seuss wrote that the Grinch's heart grew 3 times its size one day. If the Grinch had started with an average-sized heart, what would be the size of his new heart? When you're given the scale factor, to find your new image, all you do is take your dimensions and multiply it by the scale factor. So we have 3 dimensions here. We had a height of 5 inches, a width of 3.5 inches, and a length of 2.5 inches, assuming that the Grinch had a normal human-sized heart. If it grew 3 sizes that day, all you're going to do is multiply them by 3 to get your new image. What is the size of his new heart? Well, go ahead and take a minute, multiply those on your calculator or on your paper, and get your answer. These are similar figures, so the heart stays in the same proportions and the whole thing grows or the whole thing shrinks. We know since the scale factor is more than 1, this is an enlargement. It's getting bigger. So hopefully you have 15 inches tall, 15 inches tall, 10.5 inches wide, and 7.5 inches long. And the last thing we need to talk about for our learning target is being able to identify which figures are similar. So we're going to use this idea of proportions. If the rectangles are similar, the ratio of their corresponding sides will be equal. So let's check that. We have 3 rectangles, so we're going to have to check three different proportions. We're going to compare J and K and see if those are equal. Then we're going to compare J and L, see if those are equal. And then we also have to compare K and L. So you have to compare them all to each other. So let's compare J and K. First, I want you to write a ratio of corresponding sides. So 10 corresponds to what on K? Well, 10 corresponds to 5. If these rectangles are similar, this ratio will equal the ratio of the other corresponding sides. So it would be 4 to 2. The way we can check if 2 ratios are equal, we did this already this chapter, you can cross multiply or you can reduce. I like to cross multiply. So let's check it. 10 times 2, does that equal 4 times 5? Yes. So J and K are similar. Let's see if J and L are similar. Compare J and L, set up a ratio. So 10 on J corresponds to what on L? 12. Those are both the heights. Then that should be equal to the other corresponding sides. Make sure you pull from the same rectangle first. So we went from 10 to 12. Now we're going to go 4 to 5. Let's cross multiply and check this. 10 times 5, does that equal 12 times 4? No, these are not similar then. So J and K are similar. J and L are not similar. Last one to try is K and L. So try this one. 5 would correspond to 12, the height to height and the width to width. So 2 would correspond to 5. Both the tops came from K, both the bottoms came from L. Let's cross multiply and check. These are not equal. We have 25 equal to 24, and that doesn't make sense. So the only rectangles that are similar are J and K. Last question, if you want to try it, this is optional, this is just completely a challenge, is I have the dimension of Vince Van Gogh's Starry Night with a throw blanket, and I wanted you to compare to see if the throw blanket is similar to the original painting. I'll post the answer on Blended Schools.